All right. Good evening, everybody. I hope you can hear me all right. Um, so, all right. So, welcome to the second live session of the NPTEL course Essentials of Data Science with R Software, Part 1, which is covering the topics of probability and statistical inference. So, I would just like to remind you a few things in case some of you have joined us for the first time and you were not here in the last class. And then I will move on to some of the queries that were there at the last time, and then we can start today's session. Okay, so I'll just share my screen. And also this course, this particular live session is meant to be an interactive one. So please feel free to unmute yourselves and ask questions, any doubts, anything you want me to repeat. Just unmute yourself, or you can always write it in the chat box. All right. Okay, so I will share my screen. Okay. My screen should be visible now. Okay. So the way the live sessions for this course is they're going to work is that for every week. So every week on Fridays, you have the new content being released. And the following week, there would be 3 live sessions, one on Fridays, one on Saturdays, and one on Tuesdays. And these are the timings, and you can attend any one or more of these depending on what you want to get out of those. So the basic idea for all of them is that we had 3 different PhD students who will be taking each of the sessions. They would mostly cover similar stuff, but there could be some differences. So you're free to attend as many and whichever ones you want. The content is going to be a summary of what was discussed in that week. There would be a few practice questions which cover the topics that were covered that week. And starting next week onwards, we will also take a look at the previous week's assignment solutions. So in case something is missing or you have some confusion about any of the questions, we can take a look at that. All right. So I would be taking the ones on Fridays, the one that you've joined currently, and this is going to be on Zoom. The meeting link stays the same. The recording, so as you can see, the live session is being recorded, right? I was not able to record the last week's sessions due to some technical glitch, so I re-recorded it and I've uploaded it to YouTube. But I hope this week it is being recorded anyway. Any material that we discuss in these classes is going to be uploaded to a Google Drive. You will also have the access to that. Finally, so the way it's going to work is that it'll be more helpful for you if you have already seen the week's lectures and then attend one of these sessions, because we would not be covering everything in detail. It would only be a summary, and a larger focus would be on the topics that are maybe slightly more difficult. All right. But in addition to these live sessions, and if you still have any questions, there is a discussion forum which is under the heading of Ask a Question in the NPTEL page itself. You can make use of that. So for the Friday sessions, this is what the schedule is going to look like. It is a 12-week course, and you have most of the weeks you would get around 6 lectures. So the first one was done last week. Today we are conducting the second session. And yeah, so before we start, so one of you pointed out that you are not able to look at the slides which are there. So I am actually able to open the slide. So I think your name's Vardhan, right? So the way I'm able to access it is I have opened the corresponding weeks in the particular lecture. Here, like if I reload it, I would get the YouTube video, and below that there is the PPT. So you can open it. It opens up in a new tab, and this is how the PPT is visible to me, and I'm able to access it for all the weeks, like all the lectures. So I'm not sure, maybe it's not opening on a phone. If that's the case, maybe you can try it on a laptop or a computer. Give it a go, and if you're still stuck, just let us know again in the discussion forum. Let's see if I mean, since it's a Google Drive link, so it should open nevertheless. All right. And this is the Ask a Question page that I was talking about. All right. Content is blocked. Can you tell me if you're trying it on a computer or a laptop or a phone? Because if you have access to the course, you need to have the login. That's strange. I mean, because I am able to access it, and I have as much access as you do. I have also registered for the course, and that's it. So let me ask again if we can just send you a drive link, maybe, instead of a hyperlink like this. If you can just have the links, because are you able to open the Google Drive link? Let's say if I share this link with you in the chat box. Okay, let me just share it with everybody. Yeah. So this is the Google Drive link where I would be uploading the stuff that we discuss in Friday's sessions. So give it a go. In case you're still stuck, let me know by the end of this class. I'll request if the drive links can be made available separately as a document. All right. Okay. So let's start then. All right. Okay. So this top, did any of you say something? No. Okay. All right. Okay. So this week was the introduction to probability and statistics, which is going to form the basis of all the upcoming lectures in the course. This one is a relatively, the topics that were introduced here in this week were relatively simpler. They're just there as a placeholder so that we know when we use these particular terms what we are referring to, and that would help us in the upcoming classes. All right. So one of the first things that was talked about is two kinds of statistics. That whenever you hear the word statistics, you can talk about two different things. One is whether it's descriptive or it's inferential. So descriptive mostly means that you would like to talk about how a certain thing is distributed. Let's say you would just like to tell that you have a data with you, some sort of observations with you. So how many observations are there? What is the unit of those observations? A mean of that observation, mean, median, mode, things like that. How many times did something occur? So you're just telling about the data. Oftentimes your data will have a lot of numbers. Let's say if your observation was 1,000 numbers, so looking at each of those 1,000 values does not make sense, right? You will not be able to remember those. So there's no point in looking at each of them. But if you have a plot, something like a histogram, or if you have values like this is the minimum, this is the maximum, this is the average, then you get a certain picture. Or if they're following some pattern, maybe you can make a scatter plot out of it, something like that. So that gives you a picture of what the data looks like. So that is what we mean by descriptive statistics. Inferential statistics, on the other hand, is when typically you would like to compare that set of observations with something that's either already known or with a different set of observation. Okay, are the two means different? If so, how different are they? Is the distribution different? Is the nature of the distribution different? Something like that. So that will come up over time. I will not be discussing that in any more detail at the moment. Let it come. We'll talk about it as it comes. All right. And then a large part of the remaining week was about probability. Okay. So when we talk about that an experiment is happening, an experiment means that what is going to happen there is not known. You know some things that can happen. You are uncertain of what is going to happen exactly. You have a list of possible outcomes, but the exact outcome is not known. So that sort of outcome is what we're talking about, and we would mostly denote it with this sign omega. So it's not known and it cannot be known also because it is something random. But we know what all the possible outcomes can be. So that list of all the possible outcomes of a particular experiment are called as the sample space, and that is denoted with this ohm symbol. Now, you have an experiment. Now, let's take a simple example. We'll be mostly working around with a dice roll and a coin toss. So let's take the example of a dice roll. So a dice roll you know 6 options are there, right? You know all the possible outcomes. So 1, 2, 3, 4, 5, 6 can be there on the top face of a dice. So you say, okay, that's the sample space. The outcome on a particular roll of dice, you don't know. But let's say you are interested in, so you as a user, right? You as a user are interested in some of those outcomes. You may be interested in all of those outcomes, or you may be interested in one of those outcomes. But let's say you are interested in some of those outcomes. When you look at, so the whole set is a set of 6 values. You are interested in, let's say, some 3 of them. So you are interested in numbers which are greater than 3. So 4, 5, and 6. So that subset of the original sample space, you call that an event. So you as a user are interested in 3, you call that an event. And when you rolled that dice, an outcome came. If the outcome was 4, so that means that outcome happened from E. The outcome was one of the events that the outcome belonged to one of the possible outcomes that you defined. So you say that, okay, your event of interest did occur. It was indeed a number greater than 3. On the other hand, if the number was 2, you would say that, no, okay, this is not of our interest. So the event did not occur. And the way you're going to define events is through these capital letters, typically A, B, C, D, and so on. But again, this is just a nomenclature and you can change that. We'll come to the complementary aspect in a little while. Now, so we did say that outcomes, you know, one of these outcomes is definitely going to occur, but which one you don't know. But what you know is that one of them is going to occur, right? So if you define your event as everything, anything can come. I define my event as 1, 2, 3, 4, 5, 6, then of course it's going to happen. So it's a sure event. It depends on, like, we'll come through over the course of this, as the course progresses, we will come on examples where a sure event or what we call as an impossible event may be useful. But these are the two extremes. So a sure event is, it's definitely going to happen. So because you define the event as 1, 2, 3, 4, 5, 6, one of them is going to happen for sure. And for an impossible event, you say a number greater than 9, never going to happen. So that a null event or an impossible event can be defined with the symbol phi. All right. Or it's also this curly bracket. So just to remind you, so we talked about, we define these sample space, right? So the way I can define a sample space or the event, I'll call it event E is equal to, I'll use these curly brackets. Okay. And I can say I was interested in these events 4, 5, 6, and then I close the bracket. So if I don't define anything in the bracket, then that would mean I'm interested in none of the events. So, or none of the events occurred. So I can just have that empty curly brackets there. All right. And okay, again, please keep asking questions in case there's some confusion anywhere. If I've made some mistake in any of the slides, quite possible. Okay. So be attentive and be interactive. This is a live session so that it's not a one-way communication. Okay. So now, depending on how complex you define the event, it can be broadly classified into 2. It can either be simple or elementary events, and the other one can be compound events. So the ones that we discussed just now, they are simple events where so most of the events that you would think of immediately would be simple events, even numbers on a dice roll, or numbers which are either less than 2, greater than 4. So they are not a combination of anything. But compound events, on the other hand, just as a rule of thumb, easy to remember, you can say if you're defining events such that you're using the word and in it, it would most likely be a compound event. So suppose when you roll 2 dice, what's going to happen? You would say, okay, my event is I should have X so and so face on dice 1, and I want so and so face on dice 2. Or something on one coin toss and another on another coin toss, or one thing on the coin and one thing on the dice. So when you're using the word and, the events you define that way can be compound events. Again, these things are just for your information, these definitions. Most likely when you solve questions of probability, the question as such does not require you to classify them into simple events or compound events, but this is sort of theory, so we will cover it. Okay. And then when you talk about these events, a graphical description of it is going to be helpful in a lot of cases, right? So like we talked about descriptive statistics, right? So anything when you can see something pictorially, it helps you visualize those things. And that is what Venn diagrams do. So we talked about two things, sample space and events. So sample space is everything and event is something out of it. So when you just have, so when you typically just have a sample space. So again, take the example of a dice roll, 1, 2, 3, 4, 5, 6. That is denoted by this rectangle here. That's your sample space, often also called as the universe or the universal set. And then event is, let's say you're just interested in numbers greater than 3. So you denote that with a circle. Let's say this event you called E, right? So you call it E. And this was your sample space. I'll denote it with an ohm symbol. Now you can you can actually put few types of information in these Venn diagrams. So let me okay. So the first kind of information I can store in this, I can write the actual values. If they are not a lot, writing the values can be useful. So I was interested in 4, 5, and 6. And here I'm actually interested, I was remaining with 1, 2, and 3. So that's one kind of information you can write. The other information you may want to write is the number of elements that belong to each part. So here it's actually 3, and here also it's 3. And one more thing that you might want to write, can anybody tell me what other information, what other sort of description might be useful in a Venn diagram? One, you can write the elements, one you can write number of elements, and one something else. Any guesses? No? Okay. If I call this an absolute number, can you think what thing I can write here? Anything? Okay, I'm talking about proportions. So let's say I'm saying this is 0.5 or 50%, and this is also 0.5, right? 50% of the observations fall in my event, and 50% don't fall in the event. Okay. Now there are a few. So this was the Venn diagram I drew right now. There was just one event in it. So there was one event, and then there was, I can denote this actually here. So this, the remaining part here, which is not that event, so not E, that can also be called as the complement of E, and it can be denoted as E with a superscript C, or E with a bar on top of that. So that's the shaded region in this Venn diagram, right? So this one. Some other examples. So when we have 2 or more events defined for a particular experiment, you may want to look at certain the relative sort of the relation between those 2 defined events. So let's take an example, and I would just like to draw it on the next page. So again, roll of a dice. So I define my first event as all the numbers less than 4, and this one I can define as all the odd numbers up to 6, obviously. Okay, now I would like to, so first of all, I need to draw it. So what I can do, Typically, you will just draw two of these circles, call one of them A, call the other one B, and now we can fill in. So let's start off with the intersection or the common overlapping part. So you can check here that the number 1 and the number 3, they actually fall in the common part. Now, A comprised of 1, 2, and 3, of which 1 and 3 in the middle. So this can be 2. And then this was 1, 3, and 5. So this gives us with 5. The sample space in this case was 1, 2, 3, 4, 5, 6. So 4 and 6 remain. 4 and 6 go in the outer part, outside A and B, but within the rectangle. So this is how you have drawn the basic Venn diagram. Now, right now we will be talking about union and intersection and all the other examples with respect to just pictorial Venn diagram. The number thing, if some of you have already come across that, the formulas related to union and intersections, those will be covered later. All right. So right now I'm just telling you what union and intersection, what that means. So when we say A union B, in that case, we are actually looking at this whole part. Okay. So everything that was B or A. So whether it's in A or it's in B or it's in both, we would like to see all of that. So that brings us, so we have 1, we have 2, we have 3, and we have 5. So that's the union. Now, when we talk about intersection, which is drawn with an inverted U. So in that case, we are only interested in the overlap, just this bit. And that in this case is only 1 and 3. Okay. So that's union. And union means using the word or. So 2 is present either in A or in B. 1 and 3, it's present in both. So or encompasses that also. And 5 is also present in just B. But intersection, on the other hand, you need to use the word and. So it needs to be present in all the events that you're talking about. And of course, you can draw these Venn diagrams for more than 2 sets. It's easy to depict with 2, but you can draw with more than 2 also. We've already talked about complement. A few other things, subset and subtraction. So subset, if you remember from maths class, a subset would actually mean something like this. So in that case, let's say the smaller circle is A and the larger circle is B. So it's like A belongs to B. So this is it's a U pointing towards the right side. It's not a C. It's a U symbol. So A is a subset of B, or A belongs to B. And there are actually two very similar notations like this. So this, the one on the top. So can anybody tell me if you've already heard about this? What do these two depictions mean? Give it a try. I'm sure some of you would have heard about it. You can put it in the chat. You can unmute yourselves. Give it a try. No? Nobody wants to try explaining what the two symbols mean? Okay, no worries. That's okay. But try. It'll be a good practice. Just a second. Good. One of you just wrote something. Let me, share my screen again. All right. Yeah. A is a proper subset of B. Yes. So that is what the, okay. So basically the second description means that A may be a subset of B or A may be equal to B. But the first one means that A is a proper subset of B. A is definitely smaller than B. right? So let's say if you're defining B as the elements 3, 4, 5, and A is 4, 5. So A is definitely a smaller group than B, and it's contained within B. All right, so that's what subset means. And then you also have the example of subtraction. So let's say if I write A minus B, so what it means here, now A was the whole of the left circle, B was the whole of the right circle. Now I'm only interested in events of A which were not there in B. So I am only interested in this part. Okay, I'm not interested in the intersection. So basically what I'm doing is I'm subtracting. So I'm doing A minus A intersection B, right? From A, I'm removing the intersection. So that's subtraction. Okay. Now, there are also two cases. One of them is mutually exclusive events, or so if this one is going to be like this, so there's nothing common. So in this case, A and B intersection is actually null. Remember the null set or the impossible set? So that is what this is. There's no common part between them. And then another case, so let's say if I'm defining A as 1, 2, and 3, and I'm defining B as 4, and let's say I'm defining C as 5 and 6. So when I take all of them together, when I do a union of all three of them, I get my whole sample space back, right? So A union B union C, oh, sorry, this one. So A union B union C, I get my sample space back, right? So this sort of an example, when the events that you're defining, they can actually give you your sample space back, then you'll be, okay, it was not supposed to be mutually inclusive events. It would be, oh yeah, sorry, mutually, let me just correct it. This is supposed to be mutually exclusive events and mutually exhaustive events. So exclusive we just saw, and exhaustive means you, with the events you have defined, you have exhausted your sample space. There's nothing remaining. Like if you remember here in this case, 4 and 6 were remaining when you defined A and B this way. So A and B were not exhaustive. But when you're defining A, B, and C this way, all of them are able to exhaust that sample space. Okay, cool. All right. So now we have defined Venn diagrams. We'll come to a slightly different, now we'll actually define probability in that way. So the experiment you've done, rolling a dice, it has m possible outcomes. In case of a dice, m is equal to 6, right? So in case of a dice roll, it's equal to 6. In case of a coin toss, it's equal to 2. And you repeat the experiment n times. Now that n can be 10, it can be 10,000. How many number of times, right? Now, for each of the possible outcomes, you are defining simple events, right? For a coin toss, one of the events is head, one of the events is tail. For dice, one of the events is getting 1, getting 2, 3, 4, 5, 6, one by one. So you're defining simple events in that way. Now, let's say you rolled a dice 100 times and you're interested in, so event AI, so there were 6 events you're interested in, right? So you have A1, A2, all the way until A6. Now you define the absolute frequency. When you did, let's say this was, we take the example of 100 times. So you can just say, so let's say you got this 20 times, something you got 16 times, 15 times, and so on. Add up some numbers and you get something around 20. I mean, sorry, you get a total of 100. So that's the absolute number. Now for the relative frequency or the proportion, you can divide it by n. So for this case, you're going to divide it by 100. So when you're talking about the absolute frequency, you will use the notation n. So that is like the numeric value. And for relative frequency, typically your small f, lowercase f is used, right? So you're dividing the absolute frequency by the total number of events, total number of times you repeated that experiment. Now, what happens is if you're doing it a lot of times, now the keyword here being lot of times, and you're ensuring that the experimental conditions are not changed. So you're not changing the dice, okay? Not that half of things you did with different dice and other half you did with a different dice, or okay? So experimental conditions stay the same. Then what happens is these frequencies that you're talking about, so right now you can see the frequencies are all different. But when you do it a large number of times, the frequency approaches a certain value. So every time you do it, A1 will have some limiting value, A2 will have a limiting value, and so on and so forth until A6. The relative frequency of each of these. Now, A1 and A2 can also have the same relative frequency. Now, that is something that's specific to the kind of device you're using. So let's take an example of a coin where you are twice as likely to get heads. Okay. So in that case, if it's intuitive to you, I would assume that 2/3 of the time I will get heads and 1/3 of the time I'm going to get tails. So what I did was, when I toss that coin enough number of times, I'm seeing that heads, the relative frequency of getting a head is approaching the value 67%, and the relative frequency of getting a tail is approaching the value 33%. So these two numbers, they need not be equal, but every time getting a heads is approaching one value and getting tails is approaching another value. If it's a dice which is unbiased, it's going to be 50-50. For a coin which is unbiased, it's going to be 50-50. For a dice which is unbiased, it's going to be 16.67% for each of the phases. So you have absolute frequency when an experiment is repeated, you have relative frequency, and that relative frequency of that event approaches a certain value when that experiment is repeated several times. That limiting value is defined as the probability. And so what you did was you defined simple events for each of the outcomes. When you add up the probability or the relative frequency of each of these simple events, you get a value 1, which makes sense, right? Relative frequency, that's what the term relative means. You're adding up to 1, okay? So that's how probability is defined. I will come to this in a minute. There's just one slide remaining, so I'll cover this one and then we'll do a small demo in R. And yeah. So now we talked about this large N. So how large should N be? And you do, like, let's say you do 100 iterations today and you do 100 iterations tomorrow, the relative frequencies are not going to be the same, right? They'll be very similar, but they will not be the same. So, which is why setting a number N or doing it on a particular day, that does not make sense. So instead, there are 3 rules or axioms which are set forth, and it is based on these axioms that the definition of probability is accepted. Okay, so probability is a value that satisfies these 3 criteria. So for an event, its probability would fall within the values 0 and 1, which does satisfy the criteria for relative frequency, right? A sure event, or an event which you define as the whole of the sample space, will have the probability 1 or the relative frequency 1, because that is always going to happen. And when we talked about these exclusive events, which can also be called as disjoint events or disjoint sets for A, B, C, D until, let's say, A6, then when you take a union of all of them, when you add up the probabilities of each of them, then the union, since there's nothing common between them, you can just add up them as it is. So when you do an experiment enough number of times, the value that's approaching, that it approaches finally, is actually going to satisfy these 3 axioms, and that value is called as the probability of that event. That's how the theoretical definition of probability is defined. Now, of course, in real life, when you're dealing with probability, when you're solving questions, these things will not exactly be of any use. But for those of you who might be interested in mathematics and how the theory of maths is developed and how it has developed over time, it might feel a bit abstract, but this is how everything has come up. Okay, things like integration, for example, differentiation, for example, they're not just formulas. They have been developed over time through axioms like this. All right, so this is how probability is defined. And so we did just talk about relative frequencies and how you can do an experiment many number of times, and depending on how many times you do it, the value, that relative frequency approaches a certain limiting value. So we'll just take a look at how that's done. It's the same demo that you would have also seen in the lecture videos. So again, I'll just quickly tell you how I've made this thing. So this one is actually the R Studio. Okay, I'll be showing you the same demo that Sir has shown in the lectures, but he used the R console. I'm using R Studio, very similar. You can just install that R Studio. From the option file, new file, you can open an R script. This is what additional functionality R Studio gives. When you open it, the top left pane that you see here, you can type in your commands and you can save them as a document with you. The R Studio and the language R is able to recognize this because it has an extension .r. So you can see it's color coded and you can see everything. It's able to make sense. So what you can do one by one is that you can execute the commands, and the way you execute commands is that you can select that line, or you can just have your cursor on that line and you can press Control Enter or Command Enter, or you can hit the run button here. So executing commands or running commands, it's one and the same thing. Okay. And we did see this extensively in the last class. So in case you're stuck at that, you can always take a look at the YouTube video. But it's very simple. So since we are talking about R, this question was also discussed last time, that how would your exam be at the end if any of you are interested in registering for that. So the exam is going to be a computer-based test, and it's going to look very similar to your assignments that you have been solving. So you don't need, you would not have access to R or R Studio in that. You would just have a scientific calculator in case you do need to do any calculations, but they will also be a bare minimum. So the topics, any of the lectures here, especially for example, the assignment 1, there were a lot of questions which seemingly would require you to type in the commands in RStudio. But an alternate way to do that is, if you know how RStudio is going to process those commands, let's say taking the example of board mass or what is left and right and what functions are being used, you can actually try to solve those commands on pen and paper and then choose the right answer. And you can always confirm that by typing in those in RStudio or in R. Okay, so you would not have access to any of these softwares for the exam. So better not rely on it, but you need to know how it works. So I'll recommend that you try practicing and try typing it in any of the two softwares that is more convenient for you. And so you just get the hang of it and it'll get simpler. All right. So we'll be using the sample command for this. So all commands or all functions in R, it would be a name followed by a curved bracket. And if you would like to see what to type in, what inputs it accepts, here in the console where you have the greater than symbol, you can type a question mark, name of that command, followed by the curved bracket, hit enter. On the right side here, a help menu opens up, and it's going to give you a small description of what the command does, what all inputs to give it, a little explanation of each of the inputs, and also some examples at the end. So the sample function that we would be taking a look at today, it's again the same thing. You have a list of possible outcomes, which is your sample size or the sample space. That becomes your first argument or your first input. And we had discussed the last time that when you want to input several numbers together, you combine them into a vector, a data vector, which is through another function that's called C, or combine. So you have C brackets and all the possible outcomes. So for a roll of a dice, you'll have numbers 1 to 6. And then how many times do you want to roll the dice? That's the size, or the second argument here. And the third argument is replace. So now think about it. When you're rolling a dice, let's say you get the face 5. Second time, are you sure you're not going to get 5? Or 5 can be there. So 5 can be there, right? So you did not replace. You replaced 5. Replacement comes from the example that you have a bag full of balls and you've picked one ball. So did you put it back in? So can it come in the second choice or not? So in case of a dice, you do not remove the face 5. It's there. So it's still an option. So that what replace true means. Okay. So this is what you're going to write. Now it's going to give you a certain output. So if I just run this command directly, you see the command ran. So what I did was I have my cursor here and I press Control Enter. So the command got pasted in the console below and I got some output. So I got 5, 6, 1, 3, 4, something like that. I never got 2 and 4 in this because see, now there are 6 numbers, 6 options to choose from, and I've only chosen like 10 times. So it's okay if I've not got a few numbers sometimes. So I can actually save this output to a variable and use it later. So right now the environment is empty. There's nothing, I'm not storing anything in R. But now what I'm going to do is I'm typing the same command, but I'm assigning the output. So the right side is executed, and instead of printing that output in the console, the output gets stored into a variable on the left side. And I'm just calling it dice 10. It's a good practice to have your variables, the name of the variables, to be something meaningful rather than just ABCD. It's very simple to call them ABCD, but then you're going to forget what ABCD stood for. So if I do this, you can see what I got is a vector. I already know what the output is going to be, right? It's a vector, 10 numbers, and these are the 10 numbers. And now you see the numbers have changed. Okay. This number right here and this number right here. So this is what a random, so it is a random event, right? Today I roll the dice 10 times and tomorrow I roll the dice 10 times. I get different numbers. So on and so forth. I'm just changing the size argument here and I'm just storing them in different variables. So I'm selecting all the 3 together, running them in one go, and this is what I get. And all right, so I've got a list of a vector of 10 numbers, 100, 1,000, 10,000 numbers. So now I want to calculate their relative frequencies, right? To get the probability value. There are 2 more commands that we are going to use. One is length. As the name suggests, it's going to give me the length of the vector. So for the first one, it's going to give me 10, 100, 1,000, 10,000, and so on. So if I select this length of dice 10 variable, it says 10, okay? The other function, which is a more useful function, is table, which is calculating the frequency of each of the outcomes. So this is what we did, right? Absolute frequency and relative frequency. So if you remember, this is what the formula is. This is the absolute frequency of each of the events, and relative frequency is dividing it by the total number of events. So table 10, table of dice 10, it gives me the absolute frequencies. So the number, the head, the dice phase 1 came 2 times, dice phase 2 came 3 times, 3 came once, 4 also came once, 5 also came once, and 6 came twice. So it's the first entry you see here. And so if I divide the frequencies by the length, so I do table of dice 10 divided by length of dice 10, I should get the relative frequencies, which is actually the probability, right? But from your experience, you know that for a dice, probability of getting any of the faces should be 1 by 6, which is 0.167. So you can see that these numbers are not very different from that. It's not like one of them you got 90% of the time and the other you got 0, but it's still not 0.167. So let's try the same thing with the larger iterations of that same experiment. And so, yeah. So now you can see here the numbers were much away from 1.167, almost quite different here as well. But now starting when you had about 1,000 iterations, these numbers were approaching that value. And they were also approaching, they were even closer when you had 10,000 iterations, right? Yeah, okay. So this one we can discuss a little later. Okay. Now for the coin toss, I already have the commands here, but you can give it a try. I won't be showing it to you here, but you can give it a go. Try typing the actual command on your own, the sample function and the length and table function, and see as you increase the number of coin tosses from 10 to 100 to 1,000, does the value approach 50-50% or does it not approach that value? Okay, so can one of you tell me what would the basic command look like? So if I write sample, what would be inside that function? Just for anyone, let's say for 10 coin tosses. You can just type it in the chat box. No? Okay. You can try it at your time in case you don't want to try right now. That's okay. So again, I'm typing sample. Since it's a function, I'll be using the curved brackets. The first thing I'm going to write is my possible outcomes. And since it's more than one number, I can do it. I need to put it in the form of a vector. Now, here, in case of a dice, I call them as numbers. In case of a coin, I know that they are actually head and tail. So instead of, I can always assign head as one of the numbers and tail as another number. But I can also call them head and tail just as it is. And since these are going to be alphabets, I'm going to enclose them in double quotes. And then size, let's say 10 tosses. And yes, I'm replacing it, right? Because if I get head once, I can always get head again. So I ran this command and this is what I get. As the outcomes, as the outcome of that experiment 10 times. And then if I want to find out the relative frequencies, which are going to be analogous to probability, I can write, so let me save it in as S. So it will be simpler. I'll say table of S divided by the length of S. So you see, out of those 10 coin tosses, I get head 40% of the times, 4 out of 10, and tail, I got 6 out of 10. If I increase it, they'll become closer and closer to 50-50%. Okay. All right. So that is pretty much what I had as the summary of this week's session. I have 3 or 4 practice questions, but before we go there, do you have any confusion, any question about this week's topics or about the course in general? If there is, you can just put it in the chat box. Okay, now for these questions, try to solve alongside with me. Okay, so if you have an event set A and you have its complement, what is the event and its complement, what is the intersection of that and what is the union? The intersection is empty. That is correct. Empty set. That's right. And the union, that's the universal set. Perfect. Right. So let's just anyway try and draw it. So this one, this is the universe. So this is my set A, right? The circle. And this thing is A complement. So there's nothing common in those, right? So this gives me phi or the null set. And for the union, so the whole thing is the universal set or the sample space. So this A and its complement is going to give me everything. So it's again equal to the universal set. All right. Nice. So this is not exactly pertaining to the course, but it's just a food for thought for you. So like I said, typically you would see Venn diagrams with 2 or 3 events, A and B or A, B and C. Now I would draw a Venn diagram with 4 events, A, B, C, D. And now you tell me if that's correct. If it's correct, why do you say it's correct? And if it's incorrect, why do you say it's incorrect? So this is A, B, C, and D. Okay. So this is how I think a Venn diagram with 4 events should be created. Think about it. Take a minute and see if it's a correct Venn diagram. And from the question, it's obvious that it's not the correct Venn diagram. Can any of you tell me why it's not correct? So, so the thing is, maybe I've drawn it a little incorrectly. If you would draw your Venn diagram as circles, there would be a certain intersection options that would be missing. So for example, in this case, you can actually see all the options are there. But if you have perfect circles, you would see that some intersections are never present. Okay. So typically you would see Venn diagrams, 4-way Venn diagrams that look like this. This would encompass all the intersection sites. Okay. So think about it, that the more number of events you have, the more possible options are there. So let's say you need intersection A and B, you need all the 2-way intersections, you need all 3-way intersections, 4th intersection, and so on. So for 4-way intersection, these ovals are used. For 5-way, it's not a proper shape. You can take a look, just try to give it a search, and you'll see that 5-way, 6-way Venn diagrams, they are no longer circles. Okay. All right. All right. So let's say this is the question that you want, like we discussed, you as the user, you would like to, you can define events, right? So as a question, if you are to write that my event A is getting rolling the dice until an even number is obtained, or rolling or tossing a coin until a head is obtained, how would you denote that? How would you write it? So like we had discussed that this is how you typically write events, right? Something inside this. So what do you think you're going to write inside the curly bracket if your event is defined as rolling dice until an even number is obtained? Mm, So it would be a slightly different notation than what you might be familiar with, but it's going to look like this. So let's say you got an even number in the first go. So the first one was this, right? Just 2, or just 4, or just 6. Or what if you did not get an even number? So you got, let's say, 3 and 2. And right? You got 5 and 2. Or you got 1 and 2. And then also the other possibilities. So it's of the order, like let's say if you got an even number E, so it's just E, or you got odd and E, so OE, or you got odd number twice and then you got an E, so O and then E. So like that, it's you can have something like a regular expression type of a notation, and because it will be very tedious to write each of these options, each of these possible outcomes one by one. Okay. And I think this is the last question. So a random experiment can result in one of the outcomes, A, B, and C, D. And this is the probability. So 0.2, 0.1, 0.4, and 0.3. The first thing you should always check in such questions is that the values that are there, they should add up to 1. It's just like a sanity check, but it's worth doing because otherwise the question does not make sense. So these numbers, obviously, they add up to 1. Now, A is defined as events B and C, B is defined as A, B, and D, and C is just C. So so there are 2 sets of options for you. This one, I think you should all be able to solve. Come on, this one you can, yeah, okay. Right, so for the first one, this is correct. You can solve it quite easily. So B and C, so you add 0.1 and 0.4, you get 0.5. For A, B, and D, you add 0.2, 0.1, and 0.3, 0.6. And for C, it's straight away 0.4. Now for this one, so let's work it out together. So you can see that it's all talking about the same intersections and the same unions. So you can define, so A intersection B, A union B, and B intersection C, right? So A intersection B. So what do A and B have in common? Just B is common, right? And then A union B. So obviously it's A, B, C, and D, everything. And then B intersection C, there's nothing common, right? So B has a probability of 0.1. All of them add up to 1, and the null set is obviously zeros, right? So again, so you have option A correct here. All right. Also, this is just a remark. So if you take a look at the assignment 2 questions for this week, some of them look like this, right? So when events are being defined, it's like X colon or X with a pipe symbol. So this means such that. So X, it's a regular expression. That's how you can write, like you just have a small expression and you're covering a lot of numbers. So it's X such that X is greater than 3, or Y such that Y is greater than or equal to 0, less than 5, like this. So don't get confused about it. It's a simple notation. All right. Okay, so with that, so today it's a relatively shorter session. So we've discussed some of the topics, we solved a few questions. The important bit now is that the deadline for both week 1 and week 2, the deadline for the assignment is coming Wednesday, which is 7th of Feb. And for those of you especially who are interested in appearing for the exam and getting a certificate for the course, there is a certain number of assignments and a certain cutoff marks you should get in all these assignments to get that certificate, right? So don't forget any assignment. Questions are relatively simple, most of them. You should be able to solve them. So don't forget to submit the assignment, all right? Question 1 and question 2 of week 2. What about that? We would not be discussing the questions. Do you have you going to clarify something about it? Like, we will only be discussing the answers once the assignment submission is done and once you've got the marks. So next week, we will be discussing the solutions of both week 1 and week 2, but not at the moment. Okay. Right? You don't want, is there some doubt you have about the question? Okay. Unable to create the sample space. Okay, just give me a second. So week 2 quiz PDF. So I will recommend that these questions are the questions in the live sessions, the topics we discussed. This would be more than enough for the course, like for the assignments and for the exam. I can ask the instructor if there's any book or any other reading material that he can recommend for the course, and I'll let you know, or I'll put it in the discussion forum. I've noted it down. I'll ask him. So yeah, so the question week 1 and week 2, like question 1 and 2 of week 2, if I explain, there would be like we might actually end up finding out the answer. So all I can say is that think about the topic, like sit with it for a while, and you should be able to figure out the answer. Okay. All right. So if there are no other questions, I'll end the session. Okay. All right. Thank you for joining in. I will upload the recording and the reading material to YouTube and the Google Drive, respectively. So thank you. Again, if there are still any doubts that you have, there are 2 more sessions happening, one tomorrow, 3 to 5 p.m. and one on Tuesday, 6 to 8 p.m. You can join those. And otherwise, I will see you all next week, Friday, 6 p.m. Okay. All right. Thank you.